Okay, so we're still in section 4.4, but we're going to spend more time on it because I want to spend time on the applications of quadratic functions. And again, this is in vertex form. So let's read the question. So this is a typical application question that you get in this chapter. So the path of a soccer ball is modeled by h equals -1/16, bracket d minus 26 squared plus 42.25. And d is the horizontal distance in meters after it was kicked. So this is the distance, d represents the distance the soccer ball is from the player after the player kicked the ball. And h is the height in meters above the ground. So this is the height, and this is the distance the ball is from the player. Okay, so now the question asks, find the maximum height of the ball and the horizontal distance when this occurs. Okay, so looking at your quadratic again, so this is in vertex form. You should be able to read, just by looking at the equation, what the maximum height is and when it happens, what distance that is. You know it's a maximum if it opens downward, right? This a value is negative, so I know that this graph is going to be opening downward, like this, something like this, right? Now, what is this maximum height, and when does it happen? And you should be thinking that's the vertex. So if you look at this equation, there's my h value and there's my k value. So 26, and 42.25 is the vertex. Well, 26 is the x value, right, at the vertex, which is 26. There's my h value, and there's my k value at 42.25. So when the question is asking me, what's the maximum height? That's your k value. It's 42.25. And when does this occur? That's your h value, 26. Now, because this is an application, you got to remember to include units. So the maximum height, remember this is the k value. And when it occurs is the h value. So you're going to tell me that the maximum height is 42.25, and it's in meters. When does this occur? Well, it occurs when the distance is 26 meters from the player. Okay, so the max is always your k value. When it occurs is your h value. Okay. So now what we're going to do is we're going to sketch the path of the ball. And now when we sketch this, we are not showing every transformation like you did in the assignment. We're just going to show the final graph. And once again, because this is negative, I know it opens downward. Okay, so I do all my calculations before I begin, before I start graphing it. So I know the vertex. I know it's at 26 and 42.25, okay? And I'm just going to rewrite the equation just quickly here. I need a starting point, okay? And keeping in mind, this is the height of the ball. This is the distance the ball is from the player. A good starting point would be when the distance is 0 meters from the player. So in other words, when the ball is at the player's foot. Okay, because this is a soccer ball. So I'm going to figure out the height when the distance is 0. So I put 0 in here. Okay, and then of course I follow my order of operations. So figure out what's inside the bracket first. So this is -26 squared. So 0 take away 26, -26, right? And then I take -26 and I square it, and I get 676. I'm going to multiply that by -1/16. So if I take -1/16 and I times that by 676, I'm going to get -42.25. I add 42.25, and I get my height being 0. So this is where I'm going to begin at 0 and 0. Okay, so I'm going to plot this point, and of course I'm going to plot the vertex. So let's just start there. Okay, so I know here, distance is here, and it's in meters. Okay, and here, this is my height. It also is in meters. Then of course you need your title. I'm just going to call it height versus horizontal distance. You could call it, you know, the path of a soccer ball, however way, whatever. Okay. Now I'm going to plot my point. So I'm going to plot this point here at 0, 0. Okay. My vertex is at 26. Okay. And my height is at 42.25. So I think I'm going to go by a scale of 10s here on height. Sorry, 10, 20, 30, yeah. 40, 50, and I think I'm going to go by 10s here on my horizontal distance also. Okay, so I plotted this point here at 0, 0. I'm going to plot my vertex, which is about right here. I'm going to estimate 26 to be about right there. And then I'm going to say about 42.25 is about there. Okay. And this is, it's doing one of these. It's going to go up, hits the maximum, and then it has to come back down again. Now I got to figure out where it comes back down. Okay. Don't extend this into the negatives, by the way. Don't put arrows here implying that it's going in a negative height. Okay, so if it doesn't make sense, don't do that. It did make sense in knowledge and understanding questions, but on this application, it doesn't. Now, keep in mind that a parabola is symmetrical. Okay, so if the horizontal distance is 26 meters from the player when it hits the maximum, and this is symmetrical, so this is 26, that means going from here to here, I go another 26. So if this is 0 to 26, now I go another 26, which will bring me right here to 52. Okay, so 26 plus another 26, 52 approximately. It will not, well, it is 52. And then, oh, sorry, I'm trying to graph this a little bit accurately, like that. And there you go. There is the flight path of it. So you plot your vertex, you do a starting point, and I pick 0 because it's a good starting point when the ball is at the player's foot. Because of the symmetrical nature of a parabola, it hits the maximum 26 meters away from the player, and then another 26 meters away from this vertex when it hits the ground, and we're done. Okay, so let's just quickly look at this part here. What is the height of a ball at a horizontal distance of 20? Don't go by your graph. Don't go here and try to estimate it. Okay, it's only as accurate as your graph. What you're going to do is you're going to sub in 20 for your distance here. So 20 here, and then just follow your order of operations. Okay. So here we got -1 over 16. That's -6 squared. Again, we're going to follow order of operations. So -6 squared is 36. Okay, I'm going to take -1 over 16 times it by 36. So remember, all you need to do here, to do it in one step, just take -1, this means division, divided by 16, you get a decimal, and times it by 36, and you should end up getting -2.25. Add that to 42.25, and so I get a height now of 40 meters. Okay, don't forget to include the units. So let's just see how accurate I was with my diagram. So if I go here to 20, not too bad. This here is at 40. See that? Okay, that's actually going to help me here. At what other horizontal distance is a soccer ball at the same height as in this part right here? So we have to keep in mind that this is where the ball started at 0, 0. 0 meters from the player, 0 height. Then it reaches this height of 40 when it's 20 meters away from the player. Then it hits the maximum height at 42.25 when it's 26 meters from the player, and then it comes back down again, right? And it's at 40 again, and then it hits the ground at 52 meters away from the player. So what we're trying to figure out is, what is this approximately? What's this new height? Sorry, this new distance. The height is 40. What's the distance? And all we need to do is look at our parabola. So I know this is 20 and this is 26. So this is 6 meters away. So if I go another 6 meters away at 26, add another 6 meters away, and another horizontal distance is at 32 meters. So once again, what did I do? At 20, it's 6 from the vertex. Go another 6 on the other side. Find its symmetrical portion right here. So 26 plus that 6, 32. And that's it.